Hello. This is video chapter 4, section 4.2 in statistics, measuring strength of association with correlation. So where we left off, we had our number of powerboats registered and number of manatees killed, and we said this is a strong relationship. But you may not like that answer. You may say, what do you mean strong? Is it really strong, kind of strong, sort of strong? So we have a number for strength, and the number for strength is the correlation coefficient. That's a number that measures the strength of the linear association between two numeric variables. So it actually measures two things. First of all, it has to be linear to do this, and it measures the strength, but it also tells you the direction. Correlation is represented by the letter R. Correlation is always between -1 and 1. It has to be a linear relationship. A negative R means it's negative association. A positive R means it's positive association. If the value is close to -1 or +1, the association is very strong. If it's close to 0, then it's weak. And correlation does not imply causation, big star, big star. Just because the two variables are correlated doesn't mean one caused the other one. It just kind of looks like it. Maybe you want to dig a little deeper, do an experiment to find out if it's true. And if we're doing correlation by hand, here's the formula here. We'll be doing it in the calculator. Okay, so again, looking at this, there's some wonderful pictures, talk about a strong relationship, no relationship, positive, negative, and I've done some examples, but remember, R of 1 would be a perfect straight line going up, R of -1 would be a perfect straight line going down, and then you can imagine all the things in between. Close to 0 would be weak all over the place. Okay, so we haven't, just to make sure we understand, correlation does not imply causation. We have some examples here, so I'll run through them quickly. So if we say that the higher your SAT score, then the higher you'll do in your GPA in college, and we said the correlation is really high, does that mean, based on the correlation, SAT causes your college GPA? And the answer is no. Remember, correlation doesn't imply causation. Correlation doesn't imply causation. Well, what if I told you that the more Mercedes dealerships there were, less crime? And the correlation is -1. So the more Mercedes dealerships you have, the less crime, high correlated. Does that mean Mercedes dealerships reduce crime? And the answer is no. Correlation doesn't imply causation. Example would be there's a lurking variable going on. For example, Mercedes dealerships tend to be in wealthy areas. Wealthy areas tend to have less crime. Many reasons there. And then what if I said that it was a low correlation between height and GPA? The taller you are, the smarter you are, and the correlation's low. Again, based on correlation, correlation doesn't imply causation. Okay? And if I had an example where it says the more police we have, the more donuts sold, and it's highly correlated, does that mean all police eat donuts? No. Correlation doesn't imply causation. So you may be thinking, well, correlation doesn't say much. Well, keep in mind, if there was no correlation at all, I probably wouldn't proceed. But if there was a strong correlation, I may spend the time and do an experiment to find out what's going on. So if we go back and look at our manatee example, how do we find correlation? Well, you have all the steps here in the calculator. I'm going to run through them with you. But I also want to point out something. If I go to my calculator and do these steps, so if I go to second mode and you hit stat calculate, first of all, you're going to be looking for a correlation button, and there is none. There is no correlation button. But as you scroll down, you're going to notice linear regression, and there's a number 4 and there's a number 8. Both of them are great. They both do linear regression. Notice the difference. If you choose number 4, linear regression, you have ax plus b. And you remember from algebra, a, the number in front of x, is your slope, b is your y-intercept. If you choose number 8, which is also good, be careful, b would be your slope, the one next to x, and a would be your y-intercept. Either one's fine. I'm going to use 4, but they're both great. Okay? And then your question is, why can't I just do correlation? Remember, correlation only works if it's linear. So we're going to do linear regression. So I'm going to do number 4, linear regression. Depending on how your calculator looks, this one I have to do second list 1, comma, second list 2. You may have the version of the calculator where it asks you list 1, list 2. Same idea. But notice when I hit enter, I get A and B, but I don't get correlation. This is a one-time only thing. If yours has correlation, your calculator's all set. If not, a way to turn that on is to hit second, 0, hold the down arrow until you get to diagnostic on. Put your little arrow on diagnostic on, hit enter, enter, and it looks like nothing happened, but you've actually turned your diagnostic on. So if I hit stat to the right for calculate, number 4 linear regression, list 1, second 1, comma list 2, second 2, hit enter. Now we have our correlation R, and we can talk about that number, and we can compare numbers. Remember, close to positive 1 is very perfect strong, so this is very strong, 0.94, and it's positive, which means the dots are going up. But I have to discuss here that your calculator also gives you some more information. So when not only does it give you linear regression, R squared, coefficient of determination, we'll talk about more later, but that's the percent of data explained by the line. So 88.6% of the data is explained by the line. What do I mean by line? Well, it also gives you the line that goes through the data. And we'll talk about this a little bit later, but notice if your data is linear, it kind of forms a line. Your calculator takes all of the points and finds the best fit of that line, and that fit would be a slope of 0.125, let's say, and a y-intercept of negative 41.43. And we'll get back to this, and it's very important, but let's focus on the correlation. So practice, practice, practice that. And we have an example here talking about TV hours per week and GPA. So we're going to use this example to review everything we've learned up to this point. Okay? So first of all, TV hours and GPA. Just because GPA is on the left doesn't automatically mean it's the explanatory. We have to think first. So GPA and TV hours per week, what are we trying to find out here? Well, I can argue that how many hours of TV you watch explains your GPA, the outcome of GPA. So I'm going to label TV hours my explanatory, my X, put all that in list 3. I'm going to label GPA, my response, my Y, put that in list 4, because they're trying to say, is there a relation between how many hours of TV you watch and your GPA? Notice I'm not touching my calculator yet. We set everything up. So we know what our X is, we know what our Y is. We're going to put our data in the calculator in a moment, but I also want to think about my window. If the X-axis is TV hours per week, the lowest is 5, maybe I'll start at 0. And the highest is 26, so maybe I'll go to 30, 0 to 30, counting by 5s or 10s, your choice. If I look at GPA, I'm going to have a different window. I'm going to have a different axis. So the lowest is 2.0, so maybe start at 2.0 or probably a little bit before, like 1.5. And the highest is 3.7, so maybe go up to 4, 3.8, maybe go up to 4.0. So number 1, decide your scale. Notice here I've gone from 0 to 30, counting by 5s, and I've gone from 1 to 4.0, counting by 0.5s. Don't have to have the same scale as me, but you need to consider that first. Now I'm going to put that data in my calculator, and we'll see if we get that picture. So in my calculator, I go to, well, first of all, remember we have this other problem. So I'm going to hit clear. I'm going to go to stat, edit. I'm going to put my TV hours in list 3. I'm going to put my GPA in list 4. Then I'm going to go to second, y equals, go into plot 1, turn it on, choose scatter plot, but this time X is list 3, second 3, Y is list 4, second 4, enter, move it up, up, up. I'm not going to hit zoom 9, I'm not going to hit graph because I need to change my window, and that's why it's important to write it out first. So I've decided to go from, if I go down to my window here, I'm going to go to X minimum 0, X max 30, my scale counting by 5s, my Y minimum 1, my Y max 4, and counting by 0.5s, enter, then hit graph. There's your dots. Now we can, again, go to Y equals, plot 1's on, just double checking the other ones are off. There's your dots, we draw it, we can talk about it. So I would say this is a linear negative relationship, and it's fairly strong. So I draw the dots, and then let's do correlation. So I do stat, calculate, number 4. Again, this time it's list 3, second 3, comma, list 4. If yours asks for the list, you put list 3, then you put list 4, hit enter. Your correlation is negative. Notice it's going downward, 0.83, so that would be your correlation. Notice that it's not as strong as before, and it appears that the more hours of TV you watch, the lower your GPA is. Now, can I say TV hours causes your GPA based on correlation? No. But it appears that the more hours of TV you watch, the lower your GPA. And we can also talk about the line. So negative 0.8083x, there's your slope, and your y-intercept, just to kind of give you a preview of the next section. If I take that line, go to y equals negative 0.083x plus 4.153. Again, you need to put the x in, put the numbers in, hit graph. It puts the line through the data, and to give you a preview of the next section, it's giving you an idea of what's going on. It looks like your y-intercept is starting at 4.15, which again, sometimes your y-intercept's a little off. If your GPA the highest is 4.0, it's a little off there. Then it looks like your GPA goes down 0.083 every hour of TV you watch. But again, we'll go over those in the next section.